We're going to look at how to solve systems of equations again, but this time it's going to be with 3 variables and 3 equations instead of 2 variables and 2 equations. And I'm going to start off doing this by hand, in other words, a pencil and paper approach. These can be done on the graphing calculator, but for this demonstration it's going to be by hand. Now, even when you're doing it by hand, there's more than one technique that can be used. The first technique I want to use is a technique that uses the addition, or some call it the elimination technique. We've got 3 equations here already. We'll just call them for convenience equation number 1, equation number 2, and equation number 3. When you solve 3 equations with 3 variables by hand using the elimination technique, the idea is to take the top 2 equations, eliminate a variable, and then take the bottom 2 equations and eliminate the same variable over again. Now, of course, when I say top 2 and bottom 2, you notice that equation number 2 is going to get used twice, which is okay. Now, what I've decided to do is use equation 1 and 2 to eliminate the z. So I will sort of step off to the side here and rewrite these two, because writing them as they originally are, the z's already prepared to be eliminated. So when I add vertically here, I get a 2x, a minus y, z's cancel, and you get a 5. Now, some people would call this equation number 4. Equation number 4, again, is one that I created by eliminating the z. Now I'm going to use equation 2 and 3 to eliminate the z again. Now, equation number 2, I'm going to have to multiply all the way through by negative 2. So negative 2 times the x will give me a negative 2x. Negative 2 times minus 2y will give me a plus 4y. Negative 2 times negative z will give me a plus 2z. And all this is going to be equal to negative 2. Equation number 3 now gets copied down. It is already the way I want it. Oops, I forgot my coefficient. And again, adding, it just so happens, by luck, the x's cancel. I have a 3y, the z's cancel, equaling a negative 3. Now I can divide by 3. I get y equaling negative 1. I can take this negative 1 and I can back substitute in for y, and I'll have a 2x minus negative 1 equaling 5, which is 2x plus 1 equaling 5. Subtract the 1. I get 2x equaling 4. When I divide, I get x equaling 2. So I've got x and y so far. I can back substitute that into any of the 3 originals and get the z. So substituting into the first one, I have a 2 plus a negative 1 plus the z equaling 4. So z plus 1 equals 4. Subtracting, I get that z equals 3. So my solution is the ordered triple: 2, negative 1, 3. Now that one worked out a little bit easier than most because of the way 2 variables canceled simultaneously over here. That normally doesn't happen. That's not something you can count on happening on a regular basis. So let's come up with a new system to work on. One where the cancellation might not happen as quickly or quite so easily, where I can show you another step that might be necessary if it doesn't work out. Alright, now for the next equation, we're going to work with a x minus 2y plus 3z equaling negative 7. and a 2x minus y minus z equaling positive 7, and negative x plus 3y plus 2z equaling negative 8. I'm going to use the same technique again. This time I'm going to eliminate the x's. So equation 1 is going to get multiplied all the way through by negative 2 to give me negative 2x plus 4y minus 6z equaling 14. Equation number 2 is okay the way it is. So now when I add vertically, the x's do cancel. And what I end up with is, once again, going to be called equation number 4. So now I have to go through and use equation 2 and 3 to cancel x again. Equation 2 is once again the way I want it already. Equation number 3 I'm going to multiply through by 2 to give me a negative 2x plus a 6y plus a 4z equaling a negative 16. Again, adding vertically, the y's cancel, and I get a 5y plus a 3z, and that's going to equal a negative 9. And this can be called equation number 5. So what I have done is gone from 3 equations in 3 variables down to 2 equations with 2 variables. Once again, the way I did that was to take equation 1 and 2, eliminate my choice of a variable, this time it was an x, take equation 2 and 3 and eliminate the same exact variable again, and that'll give me 2 equations with the same 2 unknowns, which is something I know how to deal with already. So I can now get rid of the next variable, and I think I'll get rid of the z's. So I'll take equation 4, multiply it through by 3, and get a 9y minus 21z equaling a 63. Equation number 5, I'll multiply all the way through by a 7, which will give me a 35y plus a 21z equaling a negative 63. So now when I add, I get a 44y, the z's cancel, equaling 0. So dividing by 44, I get that y equals 0. So now you can go back through and back substitute. I can take the y equals 0 and put it in equation 4 or 5. So I think I'll put it in 5, and I'll get 5y, which of course we now make the substitution. And instead of 5y, it comes 5 times 0 plus 3z equaling negative 9. So that zero's out. When you divide by 3, get z equaling negative 3. So now I've got y and z. I can go back, say, to the first equation and plug back in, and I'll be able to find x. So I would have x minus 2 times 0 plus 3 times negative 3 equaling negative 7. So this is an x, that zero's out, minus 9 equaling negative 7. When I add 9 to both sides, I get x equaling 2. So there's your x, your y, and your z. Now that is using the technique that is basically the same as the elimination technique. You will find that there are some systems of equations that as you try to work them, the results turn out to be a little bit odd, and you may think you've done something wrong. This one, for example, is going to have an unusual result. So let's take a look at what's going on. we're going to pick a variable to eliminate, and I think I'll do y this time. So I'll take the first equation and multiply through by 2, and I get a 4x plus a 2y plus 4z equaling 2. Second equation is okay the way it is. So when I add, I get a 5x, the y's cancel, plus a 3z equaling 2. And again, we'll call this equation number 4. Since I got rid of y that time, I have to get rid of y the next time. Equation number 2 is fine. Equation number 3 needs to be multiplied all the way through by negative 2. So it makes that negative 6x plus a 2y minus a 2z equaling 4, actually a negative 4. When I add, I get a negative 5x, the y's cancel, and minus a 3z equaling 4. And that's equation number 5. Now, with equation number 5, I'm going to attempt to get rid of the x from equation number 4 because it's a negative and a positive 5. But here's what we're going to see happen. When we write them down and start adding, the x's will cancel the x's as we wanted them to, but the z's cancel the z's, which means we end up with a 0 equaling 6. Now, as you can see, that is a false statement. That means that this system is what we call inconsistent, which means there is no solution to this system of equations. Now, another thing that can happen is if instead of reaching a false statement like this, you were to reach, say, a true statement, like 0 equals 0, or 6 equals 6. In other words, another situation where the variables disappear, but this time a correct statement is left behind, then that is known as a dependent system. So this is basically everything that can happen as you try to solve a system of equations in three variables by hand.